guys and gals, this week we're going to do 8.2 and 8.3. It's matrix, so if you don't have your calculator handy, pause the button and get your calculator, because we're going to be doing a lot of this in the calculator. Okay, there will be some we'll do by hand at first, but you can use your calculator for some of it. Okay, so in matrices, we have an M by N matrix. Okay, and that means M rows in N columns. All right, so if I have 1, -2, 3, 2, 0, and 4, this is my matrix, okay? Then this is a 2 by 3 matrix, okay? So this M times N, I have 2 rows, and I have 3 columns, all right? And if I had one that looked like this, okay, this would be a 4 by 2. I have 4 rows, and I have 2 columns. All right. When we add matrix together, we have, we just sum A plus B, meaning matrix A and matrix B, where you take Aij plus Bij. Okay, so basically the ones that are in the same space, and these we can't add together, but the Ij is 1, 1. This is 1, 1. This would be 1, 1, 2. Okay, and this would be 1, 2. So you would add the 1 to the 1, the -2 to the -1. Like I said, these aren't going to add, but you're looking for the same places. If we take the difference, then it's A minus B, and so Aij minus Bij. All right. All right, so if we had we had my matrix A and my matrix B, and I want to add them together, then I'm going to be adding each the like spaces together. So 2 plus 4 is 6, 3 plus 6 is 9, 1 plus -1 is 0, and 0 plus -4 is -4. So that would be my new matrix here of the A plus B. All right, if I take those same matrix, but now I'm going to subtract them. All right, so I have 2 minus 4, and then 3 minus 6, 1 minus a -1, and 0 minus a -4. Alright, so this would be A minus B. Alright, the next concept to look at is scalars. And we have scalars, all we're going to do is we're going to multiply the number by each number in the matrix. Okay, so 5 is my scalar that I'm going to use to multiply this matrix by. And so all I'm going to do is multiply that 5 by every single number in that matrix. So my new matrix is 10, 15, 5, and 0. Okay, so that's how that would look. All right, matrix multiplication. All right, so to form the product, AB of the two matrices the number of columns in A must equal the number of rows in B. Okay, so that's the only way that you can multiply the matrices together. All right, so if we have M times N of A and M times N of B, this N and this M, those two terms must be equal, okay? If they're not equal, you cannot multiply the matrix together. All right, so if we have all right, so you can see we have a 2 by 3 and a 3 by 2. So the 3's, they match up, and so we can multiply these together. And so to do so, we're going to multiply the first row by the first column. Okay, so it's going to be 2 times 1 plus 1 times 0 plus negative 3 times 1, and that's going to go in you add all that up, now we'll go into our first spot on our new matrix. Alright, so like I said, we multiplied the first row by the first column. Alright, then we're going to do the first row by the second column. Okay, and so we're going to add those up, and that'll be our next spot. Alright, then second row by first column. And then second row by second column. Okay. All right, so then when we add all of those up, our resulting matrix is going to be -1, -6, and 2, 2. All right, so this 2 by 3 and 3 by 2, the resulting is a 2 by 2 matrix. All right. If we had, we'll just keep that first one there. And I had this matrix here. Okay, so this is a 2 by 2. We cannot, the 3 and the 2, they do not match. So we cannot multiply them together. So this would be not defined. Alright, so identity and inverse matrices. The identity matrix is it's always going to be the like a square. Okay, so IN actually it doesn't always have to be this way, but this is what we're doing. So is that right? Identity matrix of order n times n. All right, and so when you have that, it's the ones are on the main diagonal, and then there's zeros everywhere else. All right, so I2 looks like that. That's the identity matrix of a 2 by 2. Okay. If we had I3, it's going to look like that. So there's the ones on the diagonal and then zeros everywhere else. And we'll just do one more, I4. Again, the ones are on the main diagonal. This is a 4 by 4, and then we have the zeros everywhere else. Okay. So that is everything on 8.2. 8.3 picks up right where this leaves off. Okay. So we're talking again. We've talked about the identity matrix, and now we're going to look at the inverse of a square matrix. Okay. Alright, so if AB equals BA, then it's going to be, it will come out to be an identity matrix in that B is the inverse of A. Okay. We can also say that B looks like this. A, the negative 1, that is A inverse. Okay. All right. Not every square matrix has an inverse. All right. But if they do, then, like I said, you do the multiplication of the two, it'll equal the same, which will come out to be one of these, something like this, or a greater order. Okay. And then, or we can look at reverse. If it comes out to this, then we know that B is the inverse of A. Okay. All right. So we are going to verify an inverse matrix. So we have our A is 3, negative 1, negative 2, 1. And B is 1, 1, 2, 3. And we want to prove that A and B are inverses of each other. Okay. So when we go to, we multiply these out. I'm side by side now. So remember, when we multiply, we're going to do first row by first column. Alright, and then second row by first column. And So when we add all that up, we get 1, 0, 0, 1. And so yes, A and B are inverses of each other because we get the identity matrix when we multiply them together. Okay. All right. All right, another example is we're going to prove that this matrix A we're going to prove that it has no inverse. Remember I said that not all matrices have inverses. So we're going to prove that this one has no inverse. Okay. All right, so the way we're going to do that is we're going to come up with matrix B. Matrix B is going to have X, Y, Z, W. Right. That's how I pretend. All right. So if it did have a matrix, or if it did have an inverse, then when I multiplied these together, matrix A times a matrix B, then I would have to get the identity matrix. Okay, so that's what would have to happen. All right. So multiplying this out, again, we do first row, first column. So I have 6x plus 3z, and then first row, second column, 6y plus 3w, second row, first column, 2x plus z, and second row, second column, 2y plus w. And we're saying that that equals 1, 0, 0, 1. Okay. And in saying that, then we can say that it should look like that. All right, looking at this one and this one here, if I multiply no, I'm just gonna go here. Okay, so 2x plus z equals 0. I'm going to multiply this by 3. Right. So I have 6x plus 3z equals 0. All right, so notice I already have that equation up here. 6x plus 3z equals 1. All right, they cannot equal both. They can't equal 1 and equal 0. So, therefore, we have no inverse. All right, a determinant of a matrix. For the 2 by 2s, it's very easy to do. So if we have matrix A, B, C, D, all right, to do the determinant, we go down south and then up north. And so the determinant is A times D minus B times C. All right, any ones that are bigger than that, you can do them by hand. I'm not going to make you do them by hand because they're not fun. And so you can use your calculator to do the higher orders. So a this is just also another tool to figure out if a matrix has an inverse or not. And instead of trying to do all that out. So a square matrix has an inverse if and only if the determinant of A does not equal 0. Okay. And then, if that's true, then A to the negative 1, so the inverse would be 1 over AD minus BC D negative B negative C A. Okay, so you can figure out, first you would take your matrix and determine this, and you can see over here on this one, on our A, alright, so we do 6 times 1 minus, well, it is 6, but minus 2 times 3, so I have 6 minus 6, which is 0. Okay, so we know that there is not a excuse me, that there's not a inverse for A. Okay, if that number came out to be anything else, then we can use this formula right here and figure out what what the inverse matrix will be. Okay, so we're going to look at one that we can do. All right, so we have 3, 1, 4, 2. All right, and so we're going to check this. First, we're going to do the determinant. So 3 times 2 is 6, minus 4 times 1 is 4. The answer is 2, and so yes, it does have an inverse. All right. Alright, so our determinant is 2, and so to find our inverse matrix, we have 1 over 2, because you see right here it's 1 over the determinant. Alright, and then we're going to just swap these numbers around, where 2 and 3 switch, and then these stay the same, but they're now opposite signs. Okay. Alright, so then we just multiply this scalar through. And so 1/2 times 2 is 1. 1/2 times negative 1 is negative 1/2. 1/2 times negative 4, negative 2. And then 3/2. Okay. Alright, so that is our inverse matrix. A bigger one, matrix B. Okay, so we have a 3 by 3. We can find the determinant of B, like I said, put in your calculator. And the determinant of B comes out to be negative 10. Alright, and then the inverse of B is going to be there. I didn't do this fraction. Again, you can This was just done on the calculator. Okay. All right. Last thing is we're going to solve systems with inverse matrices. Okay, so we have 3x minus 2y equals 0, and I have negative x plus y equals 5. Alright, if we put these in matrix form, alright, so we're going to have my matrix A is going to be 3, negative 2, negative 1, 1. So you see I just took the coefficients off of the x's and the y's. Okay. Alright, and then we have that, and our B matrix is 0, 5. Okay, which is just the answers here. Alright, so we're basically saying that A times x equals B. Alright, first thing we want to do is we want to check the determinant of A and make sure that inverse exists. So we check the determinant. That is going to come out to be 1, so we know that the inverse does exist. Okay, and so we can do that x equals A, the inverse of A times B. Okay, and then in doing that in the calculator, it's going to give us, okay, and that is our solutions. All right, so of figuring out what, if you think about this, these are two lines, and we're looking for where are they going to intersect, okay? And they intersect at the point 10, 15, right? So it's just a really nice, easy way to solve the systems. All right, if we had that was just x and y, what if we throw in z? So we have 3x minus 3y plus 6z equals 20. X minus 3y plus 10z equals 40. And negative x plus 3y minus 5z equals 30. Alright, so there's my system of equations. We have 3 unknowns. We need to find out what x, y, and z are. Okay, so setting up our matrix, we're just going to pull off the coefficients. Okay. And then our variables are x, y, and z. And the solutions matrix 20, 40, 30. Alright, so again, first we want to check the determinant of A and make sure that it exists so we know that the inverse does exist. Alright, so with the calculator, the determinant of A is negative 30, so we know that there is an inverse. Alright, so x equals the inverse of A times B, and that is going to give me that solution right there. And so we know that x is 18, y is 39.3, and z is 14. And there we go. Alrighty, that is everything for the week. And like it says, 8.2 and 8.3. And if you'll have any questions, let me know. Alright.